Right now, your phone can tell where you are, within a few meters, which is terrifying because I can barely tell where my keys are, within the same building. But here's the truly strange part. GPS doesn't work because space is measured well. GPS works because time is measured, and time is wrong, not poetic wrong. Not, my ex said I was wrong. I mean Einstein level wrong that if engineers didn't pre-correct time before it even reaches your phone, GPS would drift so badly you could be at home on Google Maps while physically standing in your neighbor's living room, explaining things you don't want to explain. Today, I'm going to show you how GPS is basically a clock network wearing a location costume, and why the solution to "where am I" is secretly, what time is it? In orbit, GPS is not a map system. It's a time system. Satellites don't really tell you where you are. They tell you when they said something. Your phone listens to multiple satellites, compares tiny differences in arrival times, turns those time differences into distances, because radio waves travel at the speed of light, and then does a math ritual called trilateration to pin you down. So the whole thing depends on one sacred rule. If time is off, location is off, and Einstein walked in like, cute system you've got there. Would be a shame if time didn't flow the same everywhere. GPS satellites carry atomic clocks, not because engineers are dramatic, but because GPS needs timekeeping so precise it makes being on time feel like a fairy tale. Now here's the punchline. Satellites don't experience time the same way you do. Point too big. Einstein effects hit them at once. Special relativity, speed slows time. Satellites move fast, around 3.9 kilometers per second. Moving clocks tick slower compared to clocks on Earth. General relativity, gravity speeds time up. Satellites are far above Earth, about 20,200 kilometers altitude. Gravity is weaker up there, and weaker gravity makes clocks tick faster. One effect slows satellite time down, and the other speeds it up, and the result? Net effect. Satellite clocks run about 38 microseconds per day faster than clocks on Earth. Microseconds sound small. Until you remember, light travels about 300 meters in a single microsecond. So if you ignore relativity, GPS errors grow by roughly 38 microseconds per day times 300 meters per microsecond equals about 11,400 meters per day. That's roughly 11 kilometers per day. Host. Deadpan, which is fine if your goal is to locate yourself within the general vibe of West Africa. On screen, without relativity, about 11 kilometers drift per day. So GPS engineers didn't add relativity later. They built GPS with Einstein inside the engine. In fact, GPS satellites are launched with their clocks pre-offset, set to tick slightly slower on the ground, so that once they're in orbit, moving fast, and sitting in weaker gravity, they tick at the correct rate as seen from Earth. GPS works because time is broken, and engineers patched it before you ever open Google Maps. Here's where your brain tries to escape, because if time runs differently in different places, what does now even mean? GPS solves this not by philosophizing, but by standardizing. It uses a system timescale based on atomic time and continuously corrects satellite clock drift. So you, standing on Earth, can pretend time is a single clean line, because a fleet of satellites is sweating in orbit doing relativistic accounting. GPS is basically reality is complicated, but we need you to find the nearest shawarma. Each satellite broadcasts a message that includes precise time the message was sent, satellite position, ephemeris data, and a bunch of other system details. Your phone receives the signal at a slightly later time. The difference is the travel time. Distance equals travel time times the speed of light. Do this with at least 4 satellites, and you can solve for latitude, longitude, altitude, and your phone's clock error, because your phone clock is not an atomic clock. It is a chaos clock. So GPS isn't, I know where you are. It's, I know when I spoke, and I know where I was when I spoke. So by the time you heard me, you must be this far away. Your location is literally a time-based confession. With 3 satellites, you can get a position. If your receiver clock is perfect, but it's not. So the 4th satellite helps solve the unknown. Your clock errored at GPS doesn't just locate you. It also politely informs your phone, sweetie, your sense of time is embarrassing. Now let's time travel to the age of sails, cannon smoke, and men confidently driving ships into the wrong continent. Sailors could estimate latitude by the sun and stars. But longitude, east-west position, was a nightmare, and longitude wasn't an academic problem. It was a mass grave problem that if you can't measure longitude, you can misjudge where you are by hundreds of kilometers, hit reefs, miss ports, and run out of food while still technically near land. Empires didn't just want maps. They wanted predictable arrival. They wanted navigation that doesn't rely on hope. Sound familiar? Here's the mirror. To find longitude, you need to compare local time, where you are, with reference time back home, like Greenwich, because Earth rotates 360 degrees in 24 hours, meaning 15 degrees per hour. 1 degree every 4 minutes. So if your local noon happens 1 hour after Greenwich noon, you're about 15 degrees east or west. Depending on which way, longitude is a time difference turned into a location. That's GPS before GPS, but there was a problem. You can't carry Greenwich time across rough seas unless you have a clock that stays accurate over weeks. Survives temperature changes, survives humidity, survives violent motion, and survives sailors, the most unpredictable force in physics. Then enters the hero of our mirror story, John Harrison, a self-taught clockmaker who essentially taught ships to know where they are by giving them time they could trust. Britain famously offered a massive reward through the Longitude Act of 1714, money for anyone who could solve the longitude problem. Harrison spent decades building sea clocks, culminating in a watch-like masterpiece known as H4, accurate enough to make longitude practical at sea. Imagine being so good at clocks that the ocean stops bullying you. Both GPS and Harrison's chronometer are the same story. Humans looked at a chaotic world and said, "We will not navigate by guessing. We will navigate by measuring." And the measurement is time, longitude, time difference across Earth. GPS, time difference across space, same spell. Different era. If Newton ruled the everyday world, Einstein rules the precision world. The moment you demand meter-level accuracy, reality stops being common sense. It becomes corrections on corrections. GPS has to account for relativistic clock rate differences, the big 38 microseconds per day net, satellite, orbit variations, clock drift, signal delays through the atmosphere, the ionosphere and troposphere, and multipath reflections, where signals bounce off buildings. So when you open maps, and it says 3 minutes to destination. That COM number is sitting on top of a storm of physics. GPS is a miracle held together by math, fear, and engineers who don't sleep. And here's the part that messes with your head. GPS is a public, daily, practical proof that time is not universal. Time is local. There is no single clock that rules everywhere, which means, quietly, your phone works because our civilization learned how to do something ancient humans once thought only gods could do. Coordinate the world with invisible time. So here's the modern mirror. If your phone only knows where you are because it corrects time, then the real question isn't, where am I? It's, how many other things in life fail because we don't correct the hidden variable? Relationships fail because we ignore timing. Businesses fail because they ignore timing. Nations fail because they ignore timing. And GPS succeeds because it assumes time will betray you, unless you account for it. Einstein didn't just bend physics. He bent engineering. So yes, GPS works because time is broken. And the fix is not pretending time is simple, but building systems smart enough to live in reality as it is. And the next time your phone says, "You have arrived," just remember a few satellites moving at thousands of meters per second in weaker gravity, with atomic clocks pre-corrected for relativity, all agreed on what now means. Just so you could find a restaurant.host. Smirk humanity is incredible. If you enjoyed this, subscribe, because on this channel we chase the weird truths behind normal life. And drop a comment. What other everyday tech do you think hides a deep law of the universe?